I would like first to thank the euphoria of Iraklio and of Ios Nikolaos that permitted our works, and INSTAP as well as the French School for Financial Support. So our presentation will be based mainly on the results of analysis of plant remains from recent excavations at Malia, in the area P mainly, but we will briefly mention all the sectors of the site for which some information on vegetal remains is available from the Quartier Mu, the Quartier Nu, and the Abord Nord-Est du Palais. One of the aims of the program now completed in the area P was to provide a better understanding of the relationships between the urban population of this domestic quarter and the surrounding countryside. The research focused on the Neo-Palatial period between the 17th and the 15th century BC, from Middle Minoan 3A to the abandonment of the building in late Minoan 1A, that was the less well-known period at Malia. The settlement was then declining and was less densely occupied than during the Proto-Palatial period, but the palace was still in use and the site certainly still had an urban aspect. However, we can't present for the moment a picture of the exploitation of vegetal resources on the long term. Another difficulty for the interpretation is that most of the material under study was not in situ. It mostly comes from fields packing the roofs, but when we discussed that with Maria Dinu, she pointed that nevertheless, such debris accumulations of several clearing operations that incorporate firewood remains are very welcome for wood charcoal analysis. They provide a synthetic view of the woodlands and other plant resources that were systematically managed in Neo-Palatial times. Here, we will attempt a combined archaeobotanical presentation of macro and micro plant remains from Malia, from the town of Malia, aiming to assess aspects of crop cultivation, land use, and management of woodland resources during the Neo-Palatial period. In so doing, we will present the results of the study of wood, charcoal, and non-wood macro remains alongside starch analysis carried out at the sites. The presentation will gradually reduce the focal length from the woodlands and the vegetation to the fields and crops, and lastly, food preparation. So Anaya, if you want to say some words about the methodology.
Yeah, sure. Can you hear me? Yes.
Yes.
Well, I mean, the methodology we used at Malia P, House P, is the same that we orthodoxically we use in many sites. It's the flotation method, as you see up on the upper part of the slide. We use a barrel and we use a mesh, which is a 1 millimeter diameter, about 1 millimeter diameter. And this material, we wash the material there, and it's actually separated into two groups of fines, which is the residue, which is sorted by hand, as you see in the top right hand, and the flot, which is what floats and is separated through a stereoscope microscope and separated into various kinds of bioarchaeological material. We separate all the types, the fauna and the flora. But really the preservation is very poor at P, even contrary to NU. Mu we haven't floated, but Nu we had, because we sampled the pH and it's pretty alkaline at P. So generally speaking, alkalinity is not very friendly to charred vegetable material, especially seeds. Another reason could be the shallowness of the fines, and this means that agriculture really caused lots of erosion when cultivation was taking place later. That's it, really, basically. So Maia, I think you have to go on for
Yes.
Malia.
And what is, however, surprising with this poor preservation of the seeds is that the wood charcoals were well preserved. And so there is a discrepancy that still lacks explanation.
Yes.
Then with the wood charcoal remains that were studied from protopalatial, but mainly from neopalatial contexts, destruction by fire in the buildings of Area P is rarely documented. Most of the wood charcoal assemblages originate from ashy deposits with firewood remains around Earth and from secondary destruction deposit dating to the Middle Minoan 3A, 3B, and Late Minoan 1A phases. The analysis shows the presence of several tree and shrub taxa. The list represents the diversity of the environmental setting of Malia that encompasses wetlands, the coastal plain, the foothill of the Lassithi mountains, and higher altitudes in short distance from the coasts. The earth-related deposits that incorporate firewood remains from specific areas indicate that firewood was primarily procured from the evergreen oak woodlands. An additional source would have been the pruning of tree orchards, in particular olive and almond. Pines and deciduous oaks were infrequently used. The secondary neopalatial deposits are diverse in terms of taxonomic composition. From the Middle Minoan 3A to the Late Minoan 1A, evergreen oak dominates the assemblages and becomes progressively more frequent. Olive and almond are the other two most frequent taxa, but they decrease progressively during the neopalatial period. Shrub and small trees are present in very low proportions, similarly to deciduous oak, pines, and cypress. What is mostly reflected in the anthracological results is the hinterland towards the Lassithi mountains. The anthracological study shows that mixed woodlands existed in the area and were systematically used through the Proto- and Neopalatial period. Such woodlands were mainly composed by evergreen oaks, but other trees grew in the understory, such as mock privet and strawberry tree. Deciduous oaks would have also been present in these woodlands. Pine groves might have been present on the eastern parts of the mountains bordering Malia. These woodlands were probably part of the territory that Malia was directly or indirectly managing for timber, fuel, and other woodland resources more difficult to identify, such as pitch, resins, herbs, beekeeping, mountain pastures. Prickly oak was the main firewood source. Deciduous oak and pine timbers would have been carried to the settlement for building purposes, but also for fuel. Frigana vegetation would have been the kindling at hand for domestic and workshop hearths. Tree crops, especially olive and almond orchards, were additional firewood sources through pruning. Although all woodland resources were multi-purpose, it may be possible to correlate one taxon, namely cypress, with the architecture of the buildings, as its finds are always associated with the destruction deposits. In Quartier-Mu, the wood charcoal remaining from a column in the portico I1 has been identified as cypress. Cypresses at present are more ubiquitous in central Western Crete. If the same characteristics existed in the second millennium BC, cypress might have been traded between different regions on the island. So, Anaya, for the seeds.
Yes, well, here you see a plan, a map, a table of the material found at Malia. We have the Anaya, which had about 26 samples, Quartier-Nu, which had about 200 samples, and P, which had really about 300 samples. Now you see the distribution of the various taxa here. the most common is the olive, which seems to be ubiquitous really in most samples. And this is what made us wonder and really test for pH of the soil. Rarely do we find an olive stone, for example. Everything is actually fragmented. The same goes for the almond as well. It's always fragmented. And I think, you know, the reason is really that this fragmentation is a result of, in the first place, and for olive pressing, which must have undergone a further charcoalification, because even in the samples where we find charcoal fragments, we don't find anything sometimes, none, no other charcoal plant material. So charred plant material. So in that case, we really think that there must be a reason why olive is preserved versus other things, other taxa. And this really can be measured. The level of charring can be measured, but we haven't done that yet. We haven't come to this at Malia to see if the byproduct of the olive has been charcoalified, you know, to become harder and to be used as fuel purposefully. As you see, we find also a grape, but really it's very elusive in very, very tiny fragments, and which is really problematic again. And it might be also remnants of fuels. The fig, we find it both in charred form and mineralized form. And this might be because it was buried in various environments and comes from different contexts, which the mineralized one would have been more with in a liquid environment and would have been preserved mineralized. Cereals are very rare as well. Barley is more apparent, and it's the hulled barley, but I can't even tell which variety of barley it is. The wheat, of the wheats, we have possibly Dicocum and also Turgidum, stroke Estivum. Legumes too are very rare, and as you see, I mean, we have really Lathyrus cicera and lens, which are the most common ones, but they're very rare. And we also have a possible seed. It's one of safflower, which is really very important because it's a dye plant and it's an oil plant, but we don't. Most probably, it's not used for oil in that particular case. It's used as a dye plant, and very often it's also traded as false saffron. It has the color of saffron, so it could be traded instead of saffron in order to to sell it for more money, I suppose. The next one, I think. Yes, here is an example on the left of the fragmented olives, and I photographed here the largest pieces so that you can make sense of them. Most of them are even 1.5 millimeter or even 1 millimeter of size, you know, which is really even smaller than this, much smaller than this. On the right-hand side, you see a grape pip, and this grape pip, fortunately, has been preserved whole because it obviously was imbibed in some kind of liquid, and it became mineralized. So maybe it was left in a place where wine was staying. It was left over, or you know, some kind of cesspit perhaps as well. Yeah, the next one. Ah, okay. So I think that's it. I thought we were missing one, but it's okay. I think it's Evgenia who's next.
Thank you, Anaya. Yes. So I will present some results today from the starch analysis and from the program of organic residue analysis applied in cooking vessels from Malia P. As part of a multidisciplinary study I conducted for function and use of cooking vessels from CC and Malia with a diachronical approach as part of my PhD research. First, a few words about the methodology. In particular, the content analysis applied on cooking vessels from Malia P included two methods of organic residue analysis, lipid and starch analysis. For both methods, well-defined protocols of good handling practices in the collection and preservation of samples and the extraction and preservation of residues applied. For lipid analysis, the recovery of the samples obtained with extraction of 2 grams of ceramic material from the interior surface of the 10 vessel samples by using an electric drill or by removing a small piece of the SERD. The process and the analysis of the samples with gas chromatography and mass spectrometry is being conducted at the present in collaboration with Dr. Maria Rubu at Harokobio University. For starch analysis, the recovery of the samples was a 2-step process where a dry sample and a wet sample collected from the surface of 15 vessel samples. The wet sample is further processed in the lab of School of Archaeology in University of Oxford, where we proceed with the starch extraction, the microscopic analysis, the detection of the starches, and their further characterization, which completed at the Wiener Lab at Athens. The final selection of the samples based on representative amount of vessels and took into account parameters such as vessels erosion, contamination, typological variation, and contextual information. The types of vessels selected for analysis are tripod cooking pots, cooking jars, cooking dishes, and bowls with potential cooking function. Today, I will focus on the starch analysis, and I will present briefly the results. In total, 8 different morphotypes recognized on the detected starch grains. Their characterization based on a reference collection formed particularly for this study with 41 plant species, taking into account archaeobotanical evidence from Minoan context in Crete, textual information from linear B tablets, ethnographic data regarding the consumption of edible wild plant species in Crete, and historical sources. In sum, the plant species identified on cooking vessels belong to cereals, roots, vegetables, millet, crops, or weeds, and the condiment. Also, more starches were detected, but the characterization of their further plant taxonomy was not possible. The consumption of staple foods such as cereals recognized in the microbotanical material too, when confirmed by the analysis on cooking vessels as well, but furthermore, the cereals identified in different types of cooking vessels, such as tripod cooking pots, cooking jars, and dishes, suggesting that a variety of cooking techniques, boiling, stewing, roasting, were used to prepare cereal-based meals. Also, new information introduced for the food prepared in cooking vessels with the detection of starches from a condiment of Apiaceae family, potentially cumin, which could have flavored the meal, and starches from root vegetables such as tiger nuts, which could consumed as roasted nuts or in a form of dough, as references from a wall painting from Egypt from 15th century suggest. The detection of those 2 plant categories in cooking vessels shed new light in the food consumption and culinary traditions of the settlement of Malia. Lastly, the absence of legumes from the starch assemblage clearly diverges from the microbotanical evidence. This absence, among other well-preserved starches in the assemblage of Maia, doesn't seem to be related to taphonomical processes in this case. It could reflect another context of consumption instead, perhaps. It is worth to mention that legumes are not referred in the administrative Minoan records of linear B tablets, contrary to other staple crops such as wheat and barley, or even cumin and tiger nuts. Further, study on the culinary traditions and the Minoan from the Minoan urban centers and palaces could enlighten more those questions and that are relative to food consumption and their potential relation to social, economical, political developments. That is for me, and the floor back to Maia now.
Thank you. So we will now go back to the big picture for the general discussion. it seems that vegetal remains from the town and palynological data from Malia are complementary, and they reflect the diverse and environmental setting that this palatial center managed. Aside from the lowland, open and marshy areas reflected in the palynological record, there were rich woodlands in foothills and mountains to the south. The hinterland and mountains provided Malia with timber, fuel, and probably a variety of other raw materials. The survey conducted by Sylvie Müller-Selka has shown that the small settlements, numerous in the mountains during the Proto-Palatial period, were abandoned after Middle Minoan II, so at the end of the Proto-Palatial period. This descent towards the plain suggests some change in the type of exploitation of the hinterland during the Neo-Palatial period, as it has already been claimed. The palynological results seem to indicate more humidity in the area, and Isabelle Jouffroy-Bapicot and her colleagues suggested for the Lake Kaunas that it could have damaged the olive trees. Interestingly, anthracological data also show the decline of the olive towards the later part of the Neo-Palatial period. And at Malia, the lower representation of olive compared to the evergreen oak might be related to the character and the economic territory managed by this particular palatial center. The anthracological results also confirm the suggestions of Sylvie Müller-Selka regarding the existence of evergreen oak woodlands on the mountains in the physis volume. However, our anthracological record from the town reflects the continuous economic importance of the mountainous hinterland that actually increased through time. Therefore, despite the shift of the settlement to the lowlands, the exploitation of the mountains, also probably for pastoralism, and exploitation of woodlands continued, probably by means of a different economic organization in which the lowland urban centers played a central role. The rarity of seeds and of phytoliths in the samples doesn't allow to restore the vegetal landscape of the lowlands, which had to be exploited intensively to feed the town with cereals, legumes, and various tree crops. Gardens could also expand in the settlement during the Neo-Palatial period when it was less densely built. The marsh and coastal springs provided water for cultivation, but no irrigation device is evident until now in the plain of Malia. So a shift to intensive and irrigated agriculture during the Neo-Palatial period is then still a matter of debate. Lastly, and for these marshy areas, the consumption of tiger nuts identified in cooking vessels supports the exploitation of the marsh for food supplies, at least during the Neo-Palatial period. The plant of Cyperus esculentus identified commonly grows on wet soils, and their growing could be connected to this marsh, as for the flax evidenced by the seeds. The palynological analysis confirms the presence of a large proportion of Cyperaceae pollens in the marshy area, especially during Neo-Palatial period, when the environmental conditions seem to have favored their growing. Thank you for your attention. Oh, sorry, I missed the last one. Thank you.